So hello everyone, so we will talk about intermediate value theorem today. So as you see this theorem is if f is continuous on the closed interval a and b, and fa is not equal to fb, and k is any number between fa and fb, then there's at least one number c in closed interval a and b such that f is equal to k. Okay, so we need to understand what this means first. Okay, so this concept and this concept here. So from the pre-calculus, we learned about A and B, their input X, and then FA and FB, their output value basically. So we can make any continuous function such as maybe like this. Then let's say this is A and this is B. Then now this point becomes FA and this point becomes B here. So now we can generate the interval, y interval, between here and here basically. Okay. Now we can set up any another maybe y value such as here. So I'm gonna say this is k. Then we can say the corresponding c. So fc equal to k exists. So condition is k is between f and fb, or k is between fb or fa. I mean, the reason I wrote down two different ways, because sometimes we can have the graph looks like this, and then let's say this is A and this is B. Then there will be our FA, there will be our FB, right? Then FA is much higher than FB value here. And then that's the reason I wrote down two different ways. Okay. However, this theorem is not working if function is not continuous, such as. So now we have two different graphs, maybe like this, and then like that. Okay. Then I'm gonna make this is A and this is B. Okay, then A corresponds right here. So this is FA. And then B corresponds right here. So this is FB. So even now we can make an interval between these two, right? However, there's the way maybe K exists right here. Then obviously this is not belongs to either this line or these lines, right? Therefore, if line is not continuous, then we cannot apply intermediate value theorem at all. Okay? Then let's look at one example. So use the intermediate value theorem to show that the polynomial function fx equal to x cubed plus 2x minus 1 has a 0 in the interval 0 and 1. Okay, so this means we need to find out output of these two input value. Okay, so what I'm going to do, I'm going to find out f0, which is 0 cubed plus 2 times 0 minus 1, which is negative 1. f1 equal to 1 cubed plus 2 times 1 minus 1 becomes 2. So now we made f0 becomes negative 1, f1 becomes 2. Even though it is not maybe accurate graph though, if I indicate on the number line, then 0, negative 1 right here, 1, 2 right here. So something like this. Then as you see, this point is 0 basically. So we name then this is C, then we can generate FC equal to 0. And then obviously FC is between -1 and 2. So we apply this theorem and then describe that. Okay. So let's look at one more example. So given fx equal to x squared plus x minus 1 and then interval 0 and 5. We want to confirm that there is input C that will have 11 basically. Okay. So as we did before, the first step is we are finding F0 and F5 first. And then we should make sure this output must cover this output. Then we can apply intermediate value theorem. And then now, one more thing is this is polynomial function. So we can say this is the continuous function. So f0 means 1 squared plus 1 minus 1 become 1. Now f5 means 5 squared plus 5 minus 1 equal to 25 plus 5 minus 1 equal to 29, right? So now we can make f0 equal to 1, f5 equal to 29, and then let's double check whether fc equal to 11 is between these two output value. And yes, it is, right? So we can apply intermediate value theorem for this case too. Okay. Then what about the one more example? fx equal to x squared plus x over x minus 1. So this is the rational function. So now we can find out domain is x is or real value, but x cannot be 1, which means x equal to 1, we just call vertical asymptote, right? So vertical asymptote divide two different sides, like a negative side and positive side. Obviously, fx is not continuous at x equal to 1 here. Okay. Now, so we want to apply whether this is working. So let's find out the given interval, -2 and 2 here. Okay. When you look at this carefully, so we have to check x equal to 1. This is the belongs to this interval 1 first. So of course, we given question is fc equal to 6. So we're gonna find out this is true. However, this is not already the first statement. You know what I'm talking about? Yeah, because x equal to 1 is between -2 and 2 here. So we can conclude that fx is not continuous at x equal to 1, and this is the part of the closed interval -2 and 2. So therefore, we cannot apply the intermediate mean value theorem. Okay? Make sense? Alright. So, like this, so we can apply intermediate value theorem is only for the function is continuous, or even though it is not continuous function like that, the rational function case. But what if I just set up the interval maybe 2 to 6 here? If I make 2 to 6, this is totally on the right side. So I'm not sure whether this is correct graph though, but let's say this graph looks like somehow this. Then we can say this is 2 and this is 6. So as you see, between 2 and 6, the curve is continuous. And as long as there is some k located here, then we can apply fc is equal to k. That will be between f6 and f2. So we can apply intermediate value theorem. Okay, so that's all today, and then I will see you on next video.